a doodler. All right, let me situate this so that I've got it on the left and I've got my drawing tablet on the right. All right, so let's look at problem 15.
Yeah.
If the area of the rectangle is 50, what equation can I write?
So I'm trying to solve for x, so I could do x plus 10 times x equals 50.
Yeah. In other words, the area of a rectangle is the base times the height.
Yeah.
And they're telling us the area was 50, so now we have to solve that problem. Okay, what's the next step?
Multiply x and 10.
Okay. And what's the next step?
And then, let's see, add squared and 10 and then divide by 50.
Hold on. What's important here is to recognize that you're looking at a quadratic. Okay? Not only are you looking at a quadratic, but it's a very normal looking quadratic. It's got an x squared term, it's got an x term, and it's got a number. Whenever you see all three of those, the way you're always going to solve them is to put everything on one side of the equation and leave 0 on the other.
Yeah.
So I'm going to subtract 50 from both sides. Okay. Now I've got to solve that quadratic. And the way you solve these is by factoring. If I can get two things multiplied together equals 0, then I can solve it. So, can you factor that?
Yeah, so that would be like, let's see, it has a and c will equal negative 50 on top and then 10 on the bottom, and so I have to get something that is multiplies to get negative 50 and adds to get 10, right?
Well, subtract to get 10. In other words, because of that negative sign, then what I'm looking for, that tells me that my signs have to be opposite. Okay. Now I'm looking for factors of 50 that subtract, because of that negative sign, to the number 10. Well, so far I haven't found any. Why would they give you one that cannot be factored? All right, what do you do when you find a quadratic that can't be factored? How do you solve it?
I don't think I've really run into enough for.
Have you had the quadratic formula?
I don't think I do.
You've never had, you probably...
I have. I don't think I have it on my...
Okay, let me go ahead and write it.
Okay.
Where you use the quadratic formula is when you have a quadratic that can't be solved by factoring. In other words, I could not find factors of 50 that subtract to 10. I found 50 and 1, that doesn't subtract to 10. I found 25 and 2, that doesn't. I found 5 and 10, which doesn't. And there's nowhere else to go. There's no other factors of 50. So what that means is you have to go to the quadratic formula. Okay? Now, when you go to the quadratic formula, you're not really factoring. What you're doing is solving for x. Tell me what a, b, and c are in this quadratic.
A is x squared.
No, a is actually the coefficient of the x squared term.
Oh, 1, yeah, 1.
Okay, B is?
B is 10.
And C is?
Negative 50.
Okay. And now we're going to plug that in. Just a second. All right. Now, we're going to plug it in to solve for x. Okay?
All right.
So, plug in everything. What's minus b?
That'd be, would that be positive 50?
There's b right there.
Yeah.
What's minus b?
Oh, b. Okay, sorry, yeah, 10, negative 10.
Negative 10. Plus or minus the square root, what's b squared?
10 squared.
100. And then for this part, I always think it's best to just don't try to do this calculation in your head. Always substitute. Then simplify. And the bottom is 2. Okay, now we've got x equals minus 10 plus or minus, what goes inside the square root now?
That'll be 100 minus, and then multiply negative 50 times 4. So, negative 200.
Okay.
That'd be negative 100.
Well, notice it's really easy to make a mistake here. So what I suggest everybody do is do that calculation first.
All right.
What's that equal to?
That is equal to negative 200.
Okay. So now we have 100 minus a negative 200.
So 100 plus 200.
Right. And notice how easy it is to make a mistake, because you've got a negative sign in front of the 50, which means negative 50, but you've got a negative sign in front of the 4, which means subtraction. And it's real easy to mess this up. So this is why I tell everybody, first of all, spell it out exactly, and then do this as your first calculation. Come up with a number and subtract that number from 100. Okay, so now we get x equals minus 10 plus or minus the square root of 300. Well, the square root of 300 becomes 10 times square root of 3. Do you see why?
Yeah.
Because it's square root of 100 times square root of 3. Square root of 100 is 10.
Yeah.
Okay. We're still dividing everything by 2. And now we come up with an answer. In other words, now I'm going to divide the top every term by 2. So I get minus 5 plus or minus 5 root 3. So here's our two answers. X equals minus 5 plus 5 root 3, and x equals minus 5 minus 5 root 3. So those are the two answers we get, but there's a problem with this. Our answer has to be a positive number, right?
Okay.
Because we're dealing with dimensions. In other words, we're trying to figure out the width of this rectangle up here. So a negative answer doesn't do us any good. It's meaningless. So this answer here is negative. I'm going to cross it out. This is the only answer to this problem.
Okay.
Solve for x, and you did. And notice this is a positive number. Square root of 3 is like 1.71. So 5 times square root of 3 is going to be like 8.5. And subtract 5, you're going to get approximately 3.5. You don't generally, I'm not sure, it kind of depends on your teacher, but you don't generally convert these to decimals. In other words, this is the answer. minus 5 plus 5 root 3. If you convert it to a decimal, you're making it less exact. The most precise answer you can get is this one. Okay? And this tells you what the width of the rectangle is. If you want the length of it, take this, add 10 to it. Okay? All right, let's go on. I'm not disappointed that they had us have to use the quadratic formula, but that really is something you learn in algebra, and periodically you have to use it in geometry, but it's not the essence of geometry. The essence of geometry is setting up the equation for the figure that you're looking at. Okay? What's the formula for the area of a parallelogram? Let's always begin by writing the general formula. I should have done that on the last one. The last one was area is base times height. Okay? Well, for a parallelogram, what is it?
Base times height.
It is. The only difference is make sure that your height is vertical height.
Yeah.
Not slant height. In other words, it's not the hypotenuse it's not this that we're solving for. The area of this parallelogram is the base, which is x plus 6, times the vertical height, which is x, and they're telling us that area is 48. So again, we come down to a quadratic that has to be solved. Now, let's see if this one, I think this one, yeah, this is going to, maybe it's not going to solve super. In other words, this is the quadratic we get. See how I got that?
Yeah.
So now if I try to factor this the easy way, I need factors of 48 that subtract to 6. I don't think those exist either. Let's see. Notice how I factor. I start with 48 and 1. I cut it in half if I can. Double the other side. Keep doing that.
Yeah. 6, 12.
That's it. There are no factors of 48 that subtract to the number 6. So again, we're going to have to use the quadratic formula. Okay? Which is okay. It's just that I don't want to waste our whole session doing arithmetic. I'm sure you don't either. You want to do geometry. And when we're using the quadratic formula to solve for x, we're doing geometry, but that's algebra and it's mainly arithmetic. It's filling in the number and then solving and simplifying. That's algebra.
Yeah.
So I'm going to assume that you know how to solve this. But one thing you absolutely want to do in your math career is memorize this.
Yeah, especially formulas. Yeah.
Well, you're going to need it. You're not going to believe how often you're going to need it, but a lot. Okay, so memorize that, however you have to do it. I know some schools, they teach you a little song, you know, like the ABCs. I'm still not sure I would know my ABCs if I couldn't sing it. You know, A, B, C, D, E, F, G, H, I, J, K. If I couldn't do that, it'd be much harder for me to memorize it. Well, I don't know a song that they teach you, but most of my students say that they've been taught the song for memorizing the quadratic formula.
Yeah, I think I'll memorize here.
All right. Well, whatever you have to do to memorize it, do it. Okay? And math is a lot about memorizing. It really is. People who are good in math have good memories. That's really what it comes down to. And if you have real difficulties memorizing stuff, then you're going to have trouble with math because it only gets worse from here forward. Geometry has quite a bit to memorize. Algebra, not so much. With algebra, you kind of have to memorize methods more than things. But once you get to trig and precalc, there's tons of memorizing. Okay, so let's go on and get these set up rather than spending our time going through the quadratic formula each time.
Okay.
So what's the formula for the area of a square? They're telling us, I'm looking at number 17. So they're saying 36 is equal to what?
2x.
That's the height. What's the base?
Base in the height, so I got x equals 3.
Well, the base is the same as the height because it's a square. In other words, the definition of a square is 4 equal sides. So if they're telling us the height is 2x, then the area is 2x times 2x. And in fact, it's technically, there's really a different general formula for the area of a squared, and what it is the side length squared. It's not really base times height, although you get that same thing, but it's the side length squared. Okay, now let's solve this equation, which we're going to be able to do without the quadratic formula, thank goodness. What's the next line of this equation?
4x equals 36.
36 equals what?
4x.
4x squared. You have to multiply the two numbers and the two variables. Okay, what's the next line to solve this? What's the next thing to do?
Get 36 with 4x squared.
Want to get rid of the 4. In other words, if we can get the right side of this equation to say x squared, then we can take the square root of both sides and solve it. But in order to do that, I got to get rid of the 4. So I'm going to divide both sides by 4. Well, 36 divided by 4 is 9. So I get to this step. Now, I don't need the quadratic formula. I don't even need to factor it. I'm just going to take the square root of both sides. Well, that gives me x equals 3. Okay, so you got the right side length, but you didn't really show how you did it. In other words, if you were taking a test and she said, show your work, you would have lost points on this. If you only had to get the answer, you'd have been fine. I'm not sure how you got the answer, but if you had to show your work, I would show that step, that step, that step, that step, and that step. Okay. Now, the final step there is actually plus or minus 3. Whenever I am solving an equation by taking the square root of both sides, my answer always begins with plus or minus whatever it is. Always. And that is perhaps the most common mistake that all of my students make, is they forget the plus or minus. Now, and one of the reasons is when you're in geometry, you can kind of forget the plus or minus because the minus 3 can't work. We cannot have dimensions that are negative. So my only real answer is x equals 3. All right. Let's look at 18, the area of a trapezoid. What's the general formula for the area of a trapezoid?
The base 1 plus base 2 times the height.
All divided by 2. And the reason is what you're really doing is you're taking the average base and multiplying it by the vertical height. That's the real definition of the area of a trapezoid, is the average base. Well, you get the average base by adding the two bases together and dividing by 2. So this is the way that I like to teach it. I like to memorize it, and you can always get it by thinking of it like a rectangle. In other words, area of a rectangle is the base times the height. Well, this got two different bases. How about the average base times the height? Okay, they're telling us the area was 20, so fill in everything else.
So area equals 20, let's see, base 1, x plus 9 plus 3, and then plus 3x minus 1, divided by 2 times x.
Okay, simplify that. Simplify the numerator. In other words, remove the parentheses and combine terms.
Right here, so that would be, let's see, 4x plus 8 divided by 2.
Good.
Times x.
And then all of that times x. Okay, I'm going to go ahead and divide top and bottom by 2 so that this will turn into a 2, that'll turn into a 4, and I can get rid of that 2.
Yeah.
Now I've got 20 equals 2x squared plus 4x. You with me?
Yes.
Okay. Now I'm going to divide both sides of my equation by 2 because I can see there's a greatest common factor. Let's get rid of it. So anytime you can get your first term to be x squared instead of some number in front of the x, you're better off. Okay. Now, this is a regular quadratic. There's only one way I'm going to be able to solve it. That's to set one side equal to 0. Now I'm going to be looking for factors of 10 that subtract to the number 2. Well, there aren't any. The only factors of 10 are 10 and 1 and 5 and 2. So again, because I can't factor it, I'm going to have to use the quadratic. What's A, B, and C for this quadratic?
A, B, and C, A is 1, B is 2, and C is negative 10.
Good. So as long as you know the quadratic, then you can always come up with a number for x. And again, on all of these where they have to use the quadratic formula, when you solve quadratics, you get two answers, and almost always one of them's positive and one of them's negative. Okay? Well, you may be able to use, the negative one's not going to work, because x has to be a positive number. X is the height of that trapezoid. So you take your negative answer and discard it, and use just the positive answer. Okay? All right. Let's go to 19. It's the formula for the area of a triangle. The general formula.
Is base times height.
It's 1/2 of base times height. Let me show you why. If I take a rectangle, and that's base and that's height, if I put a triangle in there, it's always half of the rectangle. So the area of this triangle has to be half of whatever the area of the rectangle is, and it doesn't matter how I put that triangle in there. I can put it in there like that. I can put it in here like this. Regardless of how I put it in there, it's exactly half of the area of the rectangle. And you know the area of the rectangle is base times height, therefore the area of the triangle's got to be half base times height. Okay, now fill in everything we know.
So area equals 1/2 times the base.
Hold on, they gave us the area. What's the area?
Oh, 42.
Okay.
Equals 1/2 times the base, which is 2x plus 8, times the height, which is x plus 30.
Yeah, again, it's always, well, it's not always, but usually it's vertical height. Now, I've got to simplify this before I can solve it. Okay? But I don't like having fractions. So there's an immediate step that I can take to get rid of that 1/2. What is it?
Just divide the top by those 1 by 2. By half.
I'm going to end up multiplying both sides by 2.
Yeah.
Notice that the 2 on the right side of the equation is a divisor. It is dividing. So to get rid of it, I got to multiply. So I'm going to multiply both sides by 2, like that. That gets rid of that right there, turns this into 84. Now I still have 2x plus 8 times x plus 3, but it's a lot simpler still. Now FOIL those out and tell me what you get. Did they teach you FOIL? Did they call it FOIL?
No.
No?
I never did.
You know, I've never liked the term FOIL. FOIL means you do the first, and then the outside, then the inside, then the last. But I prefer ET. You're going to multiply every term by every term. And this works even if it's 3 terms times 3 terms. In other words, FOIL only works on 2 terms times 2 terms. Whereas ET works on everything. And what do I mean by ET? I'm going to take that term, multiply it by that. I'm going to take that same term, multiply it by that. I'm going to take the next term, multiply it by that. And I'm going to take that term, multiply it by that. And then I'm going to add everything together. So what do you get when you do all of that? And the best way to do it is to establish a pattern and always stick with it. And the pattern that I use is I go left to right. So I'm always starting with that term, start multiplying it by the other 2 terms. What do you get?
The 2x squared plus 6x.
Now keep going. Now the middle, that times that. And then finally, the 8 times the 3.
That is 24.
Okay. Now, notice that when I combine all my like terms, I get 14x plus 24. It's much harder to factor when there's a number in front of the x squared that's not 1. Okay, it just is gigantic. It's a tripling the level of difficulty. I mean, you can always use the quadratic formula, but if you're trying to factor it, it's much harder. And what do I notice here is that all my numbers are even numbers. So I can divide everything by 2.
Yeah.
So that becomes 42. That becomes x squared plus 7x plus 12. Now I'm looking at a normal looking quadratic. I got to bring my 42 over, leaving 0 behind. You always want 0 on one side. And this becomes minus 30. Finally one I don't have to use the quadratic formula on. When you're factoring, I don't know how they've taught you to factor. There's lots of methods that are taught. There's the California method, the diamond method. I have my own particular method that I like, that to me is the most understandable and least confusing. What I do is I split the x's up. That's step 1. I determine both signs as step 2. Well, both signs have to be opposite. Otherwise, I couldn't produce a minus 30. Now I'm looking for factors of 30 that subtract to the number 7 Well, if I go over here and I start factoring 30, I get this, and then I can't cut that in half, but I can cut it in thirds, which means I got to triple that. And now I can double 5 and cut the 6 in half. Bingo, I've found my two factors that I'm looking for. 10 and 3. And the larger of those factors goes with the sign of the middle term. Well, the sign of the middle term is plus, so my 10 is going to go with the plus, my 3 is going to go with the minus. There's my factor. I did not have to use the quadratic formula. What is my solution? If this is a true statement, what is x equal to?
What do you mean? Like,
Well, how do you solve it? In other words, the reason for factoring, this is probably the most fundamental rule of algebra. And that is that if you can get one thing times another thing and they're equal to 0, which is the case here, then I can set each thing equal to 0. So I'm going to set x plus 10 equal to 0 and solve it. And I'm going to set x minus 3 equal to 0 and solve it. So my solutions are x equal minus 10 and x equal 3. Make sure you understand what I did there. This is very important for algebra. Okay. Now, again, this problem was number 19. X equal minus 10 doesn't work, right? The height of that triangle, or the base for that matter, has to be a positive number. So in other words, I'm going to cross out that solution. That's called an extraneous solution. And I'm going to go with the only solution that works, where x is equal to 3. And that's the answer to the problem, is x equals 3. And you can check it. The height would be 6. The length, or the base, would be 14. 1/2 the base times the height is 7 times 6, 42. So we get the right area when x is equal to 3.
yep, sounds good.
All right. Let's look at 20. All right. Again, if they didn't give me any formula, I would need to know the formula for the volume of a rectangular brick. That's what I call this object. It's a rectangular solid, but it's a rectangular brick. All the corners are 90-degree corners. And as long as that's true, then the volume is the length times the width times the height. They were nice enough to tell us the general formula here. So, and we're supposed to find the volume, okay? What is it going to be? What's the length?
The volume equals, okay, 3x plus 1.
Times the width?
X.
Times the height.
X plus 3.
All right. Now, let's make sure we can do this algebra. And I'm not quite sure why they asked for the volume, because we can't solve for the volume. It depends on what x is. They didn't give us x, did they?
No.
So we're going to end up with the volume being a function of x, which is fine. But let's make sure you can do this multiplication. Which two are you going to multiply together first?
3x plus 1 times x.
I would actually do this one times that one.
Okay.
Only because you get an awful lot of experience multiplying binomials times binomials. Okay? So what do you get when you multiply 3x plus 1 times x plus 3?
You get 3x squared plus 9x plus 1x plus 3.
Okay. Now simplify that. You can always combine the two middle terms whenever you've multiplied two linear terms to get a quadratic.
So then that is volume equals 3x squared plus
Not yet. Hold on. I'm going to do it step by step. Okay? In other words, all I've done is simplified this. Now we can multiply by x, and the reason I waited to do it last is because that's the easiest thing to do. It's really easy to multiply something by x, so what is volume equal to?
Volume equal to 3x cubed plus 10x squared plus 3x.
Yeah. And there's the answer. It's not a number because they didn't tell us what x was. And they didn't give us what volume was either. Notice why they didn't do that. If they'd have told us what volume was and said solve for x, well, this is hard to solve for x if I have that equal to a number. That's a cubic. That's not a quadratic, that's a cubic. And you won't learn how to factor cubics for 2 more years. Okay, maybe 3. You might actually, you don't learn how to factor cubics until you get to pre-calc. So you'll be like a senior or junior before you're ever even taught how to factor cubics. And it's a lot tougher than factoring quadratics. You have a quadratic formula that you can always use to factor quadratics. There's no such thing as a cubic formula. It's a method to factor a cubic is about a 30-minute problem. You would not believe how hard it is. Yeah. It's really, really difficult when you get beyond quadratics, when you get to cubics and quartics. All right. Let's see. Is that everything? You want to send me another page? We still got 10 minutes.
Let's see. I think everything kind of translates over. I think we've all done all solved them the exact same way then.
Yeah, probably. Certainly 15 through 19 were all solved in the same way, and they were all solved for x.
Yeah, it's pretty much the same thing with the front, except instead of doing like volume and area stuff, they just give you the straight up the quadratic equation.
Okay. You can probably take a picture of it and send it to me in less than 30 seconds, I would think. Why don't you do it?
Okay. Yeah, I'll do that.
Okay. That's the beauty of the technology. It's why online tutoring is so easy to do, is because everybody has a smartphone and it only takes about 30 seconds for you to send a picture.
Oh yeah, it's really easy.
Yeah, it's fantastic. In other words, we wouldn't have been able to do this 10 years ago. You would have had to take your material and scan it into a scanner and then figure out how to send that picture. It's not as easy as it didn't used to be very easy. It's gotten to be super easy when everybody has smartphones. Tell me when it was sent. Now, my email address should be memorized by your phone. In other words, all you have to do is type the first 2 letters, DA, and it should show you my email address.
Yeah, I did. I just sent it.
Okay. I got it. All right. Yeah, the 11 through 18 are going to be typical factoring problems.
Yeah.
not requiring the quadratic formula? Let's just do a few of them to make sure that you can do them. In other words, yeah, let's do 12. In other words, we got x squared plus 16x minus 36. So how's that going to factor?
So that's going to be to find something with multiplies at 36, subtract at 16.
Uh-huh. And I know my signs have to be opposite. Well, what two numbers multiply to 36? Let's figure out what factors of 36 are. If I do my typical way. Just found them. They have to subtract to 16, right?
Yep.
There it is. Now, where's the 18 go? Where's the 2 go?
Let's see. So
A larger factor always goes with the sign of the middle term.
So x plus 18.
Uh-huh.
And x minus 2.
Correct. Okay. Let's do one that requires something a little different than factoring. Basically, number 15. There's basically 3 principles of factoring. Very first thing you should always look for is a greatest common factor. Don't have one here. Second thing you should always look for is difference of perfect squares. I've got that. That is a perfect square, that is a perfect square, and they are being subtracted. So it's the difference of perfect squares. How does that factor?
So that'd be, you have to do...
Take the square root of that minus the square root of that, always.
Square root of 64 is 8. Square root of x is x.
Yeah, and then the second term, you don't have to do any math at all. The second term is always the conjugate of the first. By that, I mean it's the same 2 terms, different sign. Now, what's my solution? In other words, since you put a 0 in here, it became an equation. So if I was trying to solve for x, what are my solutions for x?
Positive and negative 8?
This one gives you positive 8. This one gives you negative 8. And both of those work. Notice that if I plug in either of those solutions in for x, I have a proper equation. Okay. All right, let's do one more that's a little different. Nah, not really. How am I going to factor that?
So that'd be...
Notice that it's still difference of perfect squares. In other words, that is a perfect square, and so is 1.
Yeah, so all you have to do is find the square root.
What's the square root of 9x squared?
Yeah.
What is it?
3.
3x.
6, yeah.
So it's 3x minus 1. What's the second part?
And 3x plus 1?
The conjugate. Now solve it for x. So what's the first thing I can write?
So x equals...
No, go ahead and set that whole term equal to 0. In other words, this is a little harder to solve because I've got a lot of numbers in there. But if I set it equal to 0, now it's easy to solve. Now solve this.
Okay. So I have 1, 2 sides.
Okay.
And then I have 3x equals 1.
Okay.
And then I can do divide 3 by side.
Divide both sides by 3. Yeah, in other words, your last step is x equals some number, right?
Yeah. So
Well, which means you want to get rid of everything that's affecting x. So to start with, I had a 1 that was being subtracted, which means I got to do the opposite. I got to add 1. I want to get rid of the 3. Well, what is the 3 doing? It's a multiplier.
Yeah.
So I got to divide. You're always doing the opposite of whatever that number is doing. And I get x equal plus 1/3. Now, if I do the same thing for that term, I get x equals minus 1/3. Both of those are valid solutions. As you would expect, quadratics almost always give you 2 different solutions. So when you're looking at a quadratic, even though I didn't have to factor that normally, I was able to factor it using the difference of perfect squares, it's still a quadratic. Anything that has a squared term in it is a quadratic, whether it has an x term or not.
Yeah.
Okay? All right. Ben, I am going to let you go. I need one additional thing from you, and that is your mom's email address. I can get yours, but I'm going to need your mother's because that's where I'll send the envoys.
Okay. Mom? Mom? Take your email address. It's rhonda.ellis@turnkeysolutions.com.
Whoa. Rhonda, I know how to spell Rhonda. What comes after the Rhonda?
Yeah, RHONDA.Ellis, ELLIS.
So Rhonda.Ellis.
At
Uh-huh.
turnkey, TURNKEY,
Okay.
solutions.
Okay. .com?
Yeah.
Okay. That's Rhonda.Ellis@turnkeysolutions.com?
Yeah.
Okay. Rhonda, I will send you an invoice by email, and you can take care of it however you like. If you want to use PayPal, that's fine. If you want to send me a check, that's fine.
Oh, that was super. Yeah, I can figure
Yeah.
receive it.
Okay. Sounds good.
And we were talking about scheduling some time with you on Friday. Is that still okay?
Yeah, in fact, let me pull up Friday. Friday is completely, no, that's last week. This week, Friday is completely open. You have a time in mind?
Yeah, I'm thinking maybe 4:30.
Okay. I'll put you in there.
Yeah, I think that'd be the best time.
Okay. Now, the next time, well, we didn't get the audio working for some reason, but I'll bet he can get it working before Friday. We had to use the phone audio for this meeting. Okay. It actually, the audio is quite a bit better if you use the GoToMeeting audio. But I don't think he has his speakers, either they're muted or down so low that he can't hear anything out of that computer. So what I will do next Friday is go ahead and call him and see if we got the audio working. If the audio is working, then on a regular basis is all I do is text him the meeting ID number.
Okay.
And he has the software. Ben, you have the software on your computer now. It looks like a little flower. In other words, if you're looking for it, notice it looks like this flower over here, this orange thing.
Yeah.
You should have that on your desktop now. And so if you had a meeting ID numbers, all you would do is double click that, put in your meeting ID number, you're in the meeting. In other words, typically I don't need to have a voice conversation with you for you to get into a meeting. But given that we're doing audio by phone, this Friday I'll go ahead and call you and see if we've got your audio working yet. And if not, we'll just do the whole thing by phone.
Okay.
All right?
That'd be great. Thank you.
All right. Thank you. Ben, have a good rest of your week, and I'll talk to you on Friday.
Thanks. Sounds good. You too.
Bye-bye.